Good day, and welcome to an episode of my reviewer series for civil engineering topics focusing on engineering mechanics problems. For this episode, the uniform cylinder has a radius of 1 meter and a mass of 150 kilograms. Neglecting friction and the weight of the bar ADB, we are to determine the following: the normal force at C, the tension of the cable at B, and the reaction at A. To solve this, let us first recognize how the system works in this force equilibrium. So ang sabi daw, meron tayong uniform cylinder na may bigat na 150 kilograms. And base illustration, it is in contact sa point C and D. Therefore, dun sa mga points na yun madidistribute yung bigat na 150 kilogram. And with those distributed loads, dun magiging equal yung mga hahanapin nating reactions later pag nag-free body diagram tayo ng para sa cylinder. On the other hand naman, considering the bar ATB that is hinged at point A, since may dinadala siyang load from the weight of the cylinder, this is subjected to a rotational movement, so it is necessary for a cable to hold it in place. And yung cable naman na yun is nakakabit lang sa wall kung saan na rin naka-attach yung hinge ng bar. With that, let's start with our first question. Since ang force observed natin is at point C, which is yung sa contact point ng cylinder sa wall, let's observe a free body diagram considering the cylinder only. Looking at the figure, meron tayong two unknown values. Therefore, need lang natin mag-come up with two equations para masolve yung mga values na yun. Let's denote this as RC and this one naman as RD. So take note lang lagi, when it comes to determining a number of unknown variables, it is very convenient if you are able to come up with the same number of equations para makuha yung value ng mga variables na yun. Or to make it simple, lagi nyo lang tatandaan na a number of unknown variables can be determined by having the same number of equations involving those variables. Moving forward, to generate our two equations, gamit lang tayo ng summation of forces along horizontal and along vertical. Starting with our vertical forces, need muna natin i-convert yung kilogram mass into kilonewton. Kasi nga, ang hinahanap natin is in terms of magnitude of force. So to do that, force equal to mass times acceleration lang ang gagawin natin. So 150 multiplied by the gravitational acceleration of 9.81 meter per second squared, this will give us a value of 1,471.5 newtons. Looking at another force that we need to consider for our summation of forces, yung reaction at D natin is in diagonal. Therefore, need muna natin i-separate into horizontal and vertical force components. To do this, observe muna natin yung position ng direction ng force natin. We know that the reacting force at D is normal or perpendicular to the length of the bar at AD. And given that the length AD is at an angle of 40 degrees from our horizontal, pwede natin ito magamit sa point ng applied force para ma-determine yung angle ng mismong reaction from the horizontal as well. So realigning it in this sense, na makikita nyo sa screen, we can say that the angle of our reaction from the horizontal is just 90 degrees minus 40 degrees, which is just an angle of 50 degrees. Using this, pwede na natin express yung mga force components ng reaction at D in terms of trigonometric functions. With that, proceed na tayo sa pag-perform ng summation of forces. For our vertical forces, ang magiging unknown value lang natin is yung reaction at D, which we denoted as RD. And plugging in yung weight and yung vertical component na RD, sine 50 sa ating equation, we would get RD equal to 1,920.907 newtons. Bale, ang ginawa lang dito sa solution is, ang positive direction nga pala natin is downward and negative naman yung upward. In performing the summation of forces along horizontal naman, we just need to consider the reaction at C going to the right and the horizontal reaction at D going to the left. So if we are to write it in formula, this is just reaction at C minus reaction at D cosine 50 equal to 0. Solving this, we will get the value for RC, which is just equal to 1,234.735 newtons. Moving on to determining the tension of the cable at point B, this time ihiwalay natin si bar ADB and treat it as a separate force equilibrium system. So the forces acting on this bar are the horizontal and vertical reactions at A, denoted as AX and AY, reaction at D, and the tension of the rope at point B, denoted as TB. For this case, since meron tayong hinge support, and we all know that the moment at that point is just equal to 0, pwede natin to gamitan ng sum of moments approach. And if we are to take moments about the hinge, makakancel out yung reactions at A and tension at B na lang yung magiging unknown value natin. Therefore, di na natin need mag-come up ng iba pang equations. So to solve this, unahin muna natin yung tension at B. Kunin natin yung moment by multiplying its distance from point A, which is 3 meters. Then yung force applied at T, which has the same magnitude as RD, multiply lang natin by the distance from point D to A, since perpendicular naman na siya sa length ng bar. However, wala pa tayong distance value, so need muna natin to isolve gamit lang ng trigonometry. So, recall lang natin. Meron tayong 1 meter radius na measure sa cylinder natin. If we are to utilize that and imagine it in this manner, pwede tayo makabuo ng dalawang symmetrical right triangles dahil dun sa point ng contact ng circle sa wall at sa bar, or sa kahit saan pang possible contact ng isang straight line along the circumference, perpendicular lang lagi yung radius ng circle dun sa line na yun. And just to familiarize ourselves, ito yung mga tinatawag nga nating tangent line. So separating this figure muna, para di masyado magulong tingnan, we know that this line is 40 degrees from the horizontal. And given na meron tayong wall which is assumed to be an upright vertical, meron din tayong right angle na mabubuo at this point. So to get the interior angle of this figure from the bottom, minus lang natin yung 40 sa right angle na 90 degrees. So we'll get 50 degrees for this side of the figure. And since meron symmetry itong figure, following the length from point A towards the center of our cylinder, pwede natin masabi na yung angles formed by this line has equal values. Therefore, ang angle na pwede nating ma-utilize para sa right triangle na gagamitin natin is 50 divided by 2 equal to 25 degrees. Now, to solve for the measure of this side, meron tayong opposite side of the angle, which is 1 meter. And yung unknown natin is yung adjacent side. Therefore, ang gagamitin nating trig function is tangent theta. Solving for the adjacent side, we have tangent 25 degrees equal to 1 over adjacent, in which denote na lang natin to as letter A. With that, we'll get the A value equal to 1 over tangent 25 degrees. So now na may distance na tayo, multiply lang natin to sa force at D para makuha yung moment. Then equate natin tong summation ng equal to 0. Solving for TB, we will get 1,373.133 newtons. Lastly, we are to determine naman the reaction at A. Using the same figure, we have two unknowns which is AX and AY. And to solve for these values, yung two equations natin is manggagaling lang din ulit sa summation of forces along vertical and along horizontal. Performing our solution for summation of vertical, having downward forces as our positive values, ang vertical component ng force at D natin is 1,920.907 sin 50. Then ang unknown value lang natin is AY, After solving, we will get its value of 1,471.5 newtons. Performing our solution for summation of horizontal naman, having the rightward forces as our positive values, ang horizontal component ng force at D natin is 1,920.907 cosine 50. Consider din natin yung tension at B going to the left, and ang unknown value lang natin is force AX. After solving, we will get the value for AX, which is 138.398 newtons. Dahil nakuha na natin yung vertical and horizontal components ng reactions at A, apply na lang tayo ng Pythagorean theorem to get its resultant force. With that, the reaction at A is just equal to 1,477.99 newtons. So that's it. Hopefully madali kayong nakasabay sa discussion natin. With that, this situation is finally solved.